right, welcome back. We are going to now turn to page 133 in our lab manual. I would like for us to go over two examples. We'll start with the skill builder, and then we will then move down, I believe, to problem number 2. All right, so let's get started. So here we're given the following rational function. And the first thing we're going to do is look to see if we have any holes. And so we're going to look and we see that we actually do have holes. We have a common factor of x minus 1. So that x minus 1 is going to provide the x coordinate for our hole. So we set that factor equal to 0 and we find x is equal to 1. So that's going to lead us to the x coordinate of our hole, and our hole is always going to be an ordered pair. So now we need to locate the y value. So to determine the y value, we're going to take our function and we're just going to rewrite it with a little subscript r to say that, hey, we've reduced this. This was not the original. We've taken out that common factor, so we're left with 3 times x plus 3 over x minus 4. All right, so now we want to substitute in the value of 1 into that reduced function. So we have 3 times 1 plus 3 over 1 minus 4. So that's going to give us 3 times 4 over negative 3. So let me reduce that. So we end up with negative 4 for our hole. Our vertical asymptote is going to be where our denominator is equal to 0. Now, since I now have the reduced one, we'll use this one for the rest of the problem. So my vertical asymptote is going to be where the denominator goes to 0. We have one factor in the denominator, so that's going to be when x is equal to 4. All right, so questions 3 and 4 are asking us about the horizontal or slant. So here we have to compare the degree of the numerator to the denominator. And again, I can look at the original or I can look at the reduced. I say to just stay with the reduced. So the degree of my numerator here is 1 and the degree of my denominator is also 1. Since they have the same degree, that means I do have a horizontal, I do not have a slant, and I'm going to have the equation y equals 3 over 1 because I'm going to take the ratio of my leading coefficients. So my horizontal asymptote is y equals 3. X-intercepts, that's going to be where y is equal to 0 or where my numerator goes to 0. So we set this equal to 0, divide by 3, we get x is equal to negative 3, so that leads us to the point negative 3, 0. Our y-intercept is where x is equal to 0. So we're going to substitute in 0 into our reduced function. So we get 3 times 3 over negative 4. So that gives us 9 over negative 4. So that gives us the point 0, negative 9/4. All right, so now we have enough to get started with our graph. And I've already written that down in the graphing section. You'll notice that I created a little table over here. The blue values over here represent the values that we found up above, and I've already plotted those. So we have negative 3, 0, we have 0 and negative 9/4, and I also put in the hole. You'll notice the hole depicts the hole, and we also have our vertical asymptote, and I've also put in our horizontal asymptote. All right, now, you'll see that I have enough information on the left-hand side of my graph to give us a sketch. We know that we're going to look something like this. Make sure that in behavior there around the asymptotes, get close to those asymptotes. But on the right-hand side, you'll notice I had no points, so I had to use my calculator to calculate some. So I just picked some random values in that section, and I chose 5, 7, and 14. And you'll see I already have those plotted up here, and they barely fit on my paper here. And if you want, you can extend your vertical asymptote up and over just to show that your graph is actually approaching those. All right, that's it. All right, let's skip down to problem number 2. And in problem number 2, we'll notice that this one was in factored form for us, and let's look at to see if we have any holes first of all. And I see that there are no holes, so there are none. I do have a vertical asymptote where my denominator goes to 0, so that's going to be where x is equal to -2. And then now if I compare the degree of my numerator to my degree of my numerator is greater than the denominator by 1 degree. So in this case, I do have a slant asymptote, which is the reason why I went ahead and multiplied this out, just to save us some time. So I highly suggest you practice multiplying out those two binomials, and then also at the end, after you multiply, then distribute the 3. All right, so now we're going to have to do some long division. So we have x plus 2 divides into 3x squared plus 12x plus 9. So that's going to give us 3x. We get 3x squared plus 6x. We're going to subtract those. So we end up with 6x plus 9. And that's going to be plus 6. So we get 6x plus 12. And then we subtract those. And we get -3. So our slant asymptote is right here. It's y equals, got a little carried away with my circle, didn't I? My slant asymptote is y equals 3x plus 6. All right, x-intercepts. X-intercepts are where the numerator goes to 0. I'm actually going to go back to my original since it's already factored for me. That's going to be easier for me to find my x-intercepts. That's going to be where y is equal to 0. So y goes to 0 at -3 and also at -1. And my y-intercept is where x is equal to 0. So we're going to need to plug in 0 for our x. Now for this one, I'm going to use my version that's multiplied out. I think that'll go a little bit faster. So we get 0, 0, and then we end up with 9 halves. So we get, what is that, 4.5? So we have the 0.0 and 4.5. All right. Sorry about that. Okay, so let's put our lines in here. All right, so we have -2. We have a vertical. Our slant is 3x plus 6. So that means that my my y-intercept is at 6 and my slope is 3. So I'm going to have to go up 1, 2, 3 and over 1. So it's going to do something like this. And then we go down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1. So we can kind of see that our slant asymptote is doing something like this. All right, so there's our asymptotes. We'll use a different color for our points. All right, so at -3, 0, we have a point. At -1, 0, we have a point. At 0, we're at 4.5, and I believe that's all we have. All right, so again, you can build yourself a table, or you may use your calculator. So let's type this into our calculator if that's what you plan to use. And let's get some values. Using my calculator, at -4, I have a -9 halves. That's -4.5. So probably somewhere right about there. And then, so it looks like our graph then is going to be doing something like this. Oops, let me change my setting here so it doesn't try to make a line. All right, on the right hand side, so at -1, we have 0. At 0, we have 9 halves already. And at 1, we actually have 8. So it's somewhere right about there. So I think it's safe to say that our graph is going to be getting close to our slant asymptote. It's kind of hovering, but then it starts to take over the shape of that vertical asymptote. So we end up with a rational function that looks something like this. All right, good job.